Hey, hi everyone. So thank you for joining the session. I'm sharing my screen and let me know if you're able to see it.
Yes, we are able to see it, Lokesh.
Okay, that's good. So I'll be talking about the Cosmos DB primarily, and this is something that I've learned from my previous project. Something new that I've learned. I think somebody is not on mute. Can everyone be on mute, please? Yeah, thank you. Yeah, I was getting some static. So yeah, so coming back to the topic for today, I got a chance to work on Cosmos DB live migration. We'll soon discuss, what is live migration and what is Cosmos DB. So we'll go on a journey where we will try to understand the basics of Cosmos DB, not go into advanced details, and then the last 20 or 25 minutes will limited to the demo session where I'll try to show how we did the migration. As I said, it was a good learning curve, so I hope I can share something valuable with you guys so that you can also do the demo. Just a caveat here is if you're not from the database or data world, you might not find easy to relate certain terms, but that should not stop you from doing the demo session. So at the end, I'll lay out what services you need in order to do a demo at your end. In any ways, even if you're working in front end applications, the Cosmos DB would play a major part. So if anything, you will definitely get a brief idea of Cosmos DB, what it is, and how we are going to use it in the session. So with that said, the agenda would be, as I said, would be on Cosmos DB introduction, and then we'll discuss some important concepts that would be used in our demo session. So without these concepts, we might not be able to relate the things. So it's important to understand those concepts. So let's straight away dive into it. So the official documentation or definition of Cosmos DB states that Azure Cosmos DB is a globally distributed multi-model database service offered by Microsoft Azure. It is designed to provide high availability, scalability, and low latency access to data for mission critical applications. Unlike traditional relation databases, Cosmos DB is a NoSQL database, which means it can handle unstructured and structured data types. Now, it's I mean, if you're hearing about it for the first time, you may find this definition a little overwhelming, but we will focus on two or three key terms here. One is the globally distributed. What do we mean by that? Multi-model. What do we mean by that? And how I know it provides low latency. So we'll try to understand this definition by looking at these three terms. That is globally distributed, multi-model, and we'll also be talking about low latency. Now, uh, if you look at the literal meaning of cosmos, that basically means the universe, right? So that somehow should trigger a thought process in your mind that this database is designed so that any application around any part of the world can use it with low latency. Why we are using low latency here is because the data access time will be significantly reduced. And why it would be reduced? Because you will have multiple copies of the data available in different parts of the continent. So you can see this diagram where in this particular case, the primary copy, the only copy that currently exists is in the East US, if I'm not wrong. Sorry, it's West US. And then you have an option to replicate the data in various other parts of the continent, and not only in America, North America. You can have an option. You have an option of replicating the data in South America, Africa, and multiple regions in Europe, Australia, and India. So um, how does it matter? Let's say you have a social media website, similar to Facebook, and you want to have its presence all over the world. Now, what we would need to do is there are two things that would come here. First is all these social media websites, they have unstructured data or semi-structured data. So that can be used. So Cosmos DB can be used to store it. And secondly, you can have all these regions activated so that your data is replicated. Because going back to the on-prem world, if you are coming from a background where you did not have to work on cloud technologies, uh, there is a server and there is an front-end application. If the physical distance between these two, so for example, let's say I'm accessing the information from a server that is situated in US. So due to some network constraints and network protocols, there is bound to be some latency. Latency is nothing but the time it takes for the signal to travel from source to destination. And in order to avoid that, you would, or I would ideally want the servers to be located in India, because if that is the case, the latency will be low, which means that the response time will be quicker and will get more out of what we're using. So it's I mean, I've tried to simplify it in a much better way, but it's not that simple. But if you, especially if you're not heard about the Cosmos DB, you can use this example in order to understand it. So all these regions can be activated just by the click of the mouse, and with that you can enable multiple regions. There is also something called read regions and write regions. Again, as the name suggests, if you activate multiple read regions, those regions you'll be able to read data from. If you have multiple write regions, that means that you'll be able to not only read but also write the data. So you will have some applications. Again, if you take about the social media applications, where there is a two-way communication. You're fetching the data as well as you are inserting the data into the databases. So that comes in handy when you want to write it. So that is what we mean by globally distributed. Now, one more question that might pop up in your mind is Cosmos DB the only service that is that is there in Azure that does this globally distributed feature or gives the globally distributed feature? The answer would be no, because you have SQL Server also doing the same job. In SQL Server, you have something called geo-replication, where you can have a primary copy of your data and then you can have the secondary copies of your data. However, here you can limit the secondary copies to not more than four. If there is a requirement to have more than four secondary copies, then you might have to raise a ticket with Microsoft. It is they do not provide it out of the box. And yeah, SQL is there, but the important difference or the fundamental difference between SQL and Cosmos DB is that Cosmos DB is ideally suited for unstructured data, which is in other languages people call it as, or not people, I mean in the industry call it as NoSQL. So if you have an application where you want to have the data globally distributed, and it's also critical in terms of you want to have low latency, and also the data is unstructured, it could be again a social media website or anything else, then your choice would be Cosmos DB. If if these are not the things that you're looking for, then probably you can go with the traditional relational databases like SQL Server and the other databases that Azure or Microsoft provides. So with that, let's also look at a brief history of how this Cosmos DB was introduced. So it started as an internal project within Microsoft, and they named it as Florence. And then in 2014, they gave an official name of Document DB. So up till 2017 or before 2017, this service not this NoSQL variation was not available to the general public. So in 2017, they released uh, you know it as a Azure service, And if if you are experienced, then you might be able to recall that from 2011-12 to maybe 2016-17, because there so much data was introduced, in the ecosystem. The term NoSQL was being floated like anything, because everyone was talking about NoSQL. So I think that might have prompted, Microsoft Azure to come up with their own offering and provide and come up with Cosmos DB. So I'm assuming that might be, the reason behind it, because Microsoft is a leading player, so they would want to have solution for all the offerings. So that is about the history. Before we look into the multi-model thing, any questions so far? Okay, so I'll take it as no. So remember, let's go back to the definition. We talked about globally distributed. We also, were using the term low latency when I was trying to explain certain things. Now let's look at the multi-model. What do we mean by multi-model? And continuing our discussion from NoSQL. So NoSQL actually comes in various, flavors. So you have a MongoDB that provides the NoSQL capabilities. And for the social media websites, you have a concept of called nodes or edges that, is called as Gremlin and Cosmos World. So basically what it means is that you can store your unstructured data in a variety of ways, and these ways have been identified already by the industry experts. And with that in mind, Azure provides different APIs. So you have NoSQL API. So this is actually NoSQL API. You have a MongoDB API, Cassandra, Gremlin, Table. So how do we easily understand this? So let's try to compare it with the relational databases. In relational databases, you will have tables. You'll have databases at the top, then you have tables, then you have rows and columns, right? So in NoSQL or unstructured, databases, we don't have any rows, any concept of rows and columns. So let's say we are talking about MongoDB. Then somebody is having application that uses MongoDB and they want to migrate it on Azure. They can simply choose the MongoDB API, and what they would be doing behind the scenes is they will be creating a collection which would be equivalent to the tables, and then rows. So this row, not to be confused with the the structured rows in relational databases. And similarly, if you're using a NoSQL API, you will talk about container and documents. This is something that we will see in action. So yeah, so the main takeaway from this slide is that the unstructured data can be stored in various ways, and Microsoft supports all the major APIs that are available in the market. So now let's take a tour of this Cosmos DB on Azure portal, and we might be able to relate in a better way. So let me just open that. So this is my subscription. So I'll go into the Azure Cosmos DB tab, and you can see that I've already commissioned a Cosmos DB account. So let me open that. So this is how it looks. Let me maximize a bit. Now, there is most of the stuff or the tabs that you see on the left are similar to most of the Azure services, but there is one tab called Data Explorer. So once you click here, you'll be able to see the containers and the items or the documents. So this is how it looks like. So this is source DB. This is target DB. So in the demo session, we'll try to move data from source DB, source container, to target DB, target container. But going back to our slide here, that in NoSQL API, you're using containers and documents. So where is that? So yeah, so you have databases at the top, then you have containers. So this is nothing but container. And you can see here we have an option to create a new container. Uh, just ignore this throughput control table, a control container. We are using it for doing some metadata operations. And inside containers, you will have items. And each item will be referred to as document. And this is in the JSON format. So I've already loaded the data so that we are prepared for the demo session. And if you want to load data, what you can do is you can go to the container and then you can click on this upload item. You first of all have to have a JSON file, an unstructured JSON file where you have all the data line, and then you'll get plenty of examples from various open source websites like Kaggle, and you can use any JSON data, unstructured data, and you can upload it. So I've already done that, and I also would like to show you a feature where you can replicate the data globally. So this is a same diagram that you saw on this slide. Now here, these are all the regions where I can just activate this by a click of the mouse, and that region will start. From that region, you will be able to start reading the data into your application. And as I told you that it's not only for the read operations, we can also enable the write operations. So you can see here, if I click on this one, if I toggle and enable this, it would make sure that multiple region writes are also are possible. So that is very easy to do. So let's see, what do we have? So yeah, this was a small tour. We will again look into it in more detail. Just a brief idea on what clients are currently using or what customers are currently using Cosmos DBs. So you can see here most of these organizations are global organizations like Coca-Cola, Citrix, and their operations are very critical to them. So again, going back to the usage of Cosmos DB, you need to have, if there is a need to have very critical support in terms of how you want to access the data, then you should be using it. Because one thing we have to keep in mind, guys, is Cosmos DB service does not come cheap. So if you can avoid that, you should do that. But if the requirement is such that the data is unstructured, we don't have much options available as far as Azure is concerned. So we'll have to use Cosmos DB. So let's move on. Any questions, guys, up till here? Okay, I think we are fine. So I told you that before doing the demo session, we need to be familiar with certain concepts. So these are the couple of concepts we'll discuss about in brief. So our first one is throughput. So what is actually throughput? So in Cosmos DBs, we represent throughput in terms of request units or RUs. Now, in order to understand it, let's take an example of this laptop, my machine. So you can see here it has a processor of i5-8250 CPU, and there is some CPU attached to it. There is some RAM attached to it. So I have two options. Either if I'm going to buy a new laptop, I'm going to say, give me i7 and give me maybe 2 gigahertz CPU, give me 30 gigabyte RAM. I'm just taking an arbitrary example. Or I can represent all of these metrics into a single term, and let's say I call that as throughput. So I would go to the shop and say I want a laptop with a higher throughput. So as you can imagine, the throughput is like nothing but a bundle term that is used to represent all these metrics. And it's not only for Cosmos DB. You will find it for Azure SQL Data Warehouse, where you use DWUs, and you will find it for Azure Data Factory, where you use data, I think, integration units. And in Azure SQL DB, I think you use DTUs. So this is something that Microsoft suggests, that in order to simplify our life, so that whenever we are talking within the team or with the client, we should not get confused with all these terminologies and metrics. We should use only a single metrics, which is throughput. And as I told you, that in Cosmos DB, throughput is represented in the form of RUs, which is it essentially means if you want to have more throughputs, you will have to pay more. Is as simple as that. So another one is for this particular demo, we'll have to do streaming. We'll be doing streaming, and specifically structured streaming. So what is actually live migration? So let's say you have a source database, you have a target database. Uh, So sorry, let's consider an example of migration. So how migration happens is, you have a legacy application, and you have a new application. In most of the occasions, you are actually moving the backend of the application. Yes, there would be chances where you move the front end as well, but for our simplicity or our demo session, let's talk about moving the backend. And what is backend? By backend, we mean the data. So, and we also have to understand that the application is very critical, so we cannot afford any downtime, uh, because if there is a downtime, there will be a loss in business, and we don't want to do that. So live migration or online migration refers to the fact that you are not taking down your application, and at the same time you're ensuring that the data is migrated. So for that, obviously, you need to have some sort of, you need to do some sort of streaming, which means that the system that we are going to use would have to continuously keep checking the source system or the source database in our example, so that it, continuously moves the data. And at the same time, you are not bringing down the application. So that is why we are going to use streaming, and we are going to use streaming in Databricks. And Databricks have done a fine job in uh, making our life easier, and they actually call it as structure streaming, which means that, so taking a step back, what happens is, there are two types of workloads. One is the batch workload, and the other one is the streaming workload. Now, batch workloads, you just load the data, and you do it on a periodical basis. But in streaming workloads, you have to continuously stream the data. Like, a very vague example would be watching a match where the video is being broadcasted live to us. Uh, and in order to understand this in a much better way, you can think of streaming as a combination of micro batches. So you have one batch after another after another. So that is why we call it structure streaming. That you know uh, you have to. I mean, again, this will be a little technical if you have not used Databricks, but there is something called data frames and delta tables inside Databricks. So what Databricks as a company have done is that we don't have to go outside of that. We can use whatever tools that are already available for us for the batch workloads, and we can use the same tools for streaming workloads. So yeah, I think that would be the right way to help you understand that structure C streaming is just an extension of batch streaming, where we uh, envision the streaming as multiple micro batches, and we use whatever is already provided to us, that is the data frame and the data table, and we just keep on adding the information. This could be a topic in itself, the structure streaming, so I would not want to confuse much on this. So with that, I think we have covered two important concepts, so I think we are ready for the demo session. So we still have 30 minutes, so let's try to cover that. So let's go to our portal. So what is the problem statement here? The problem statement here is, sorry, I think I did not talk about what we need. So we would need a Databricks account. We would need a Cosmos DB account. And just to help us visualize what is happening, we will also need a Power BI account. If that is not there, no problems. We can still, do our job. And then, I mean to say, if Power BI is not accessible, we can still understand how this, migration works. But it would be good to have that, Power BI so that we can visually see what is currently happening. So let's go to Data Explorer here. So you have a source database. So the problem statement is we want to move the data from source container to the target container. And what kind of data it is? It is a Volcano data that I downloaded from some open source website, and it's in JSON format. And it actually represents the volcano name, the country where the volcano is situated, some other important information like what was the last known eruption, what type of volcano is there. So that type of data is available here. And if you query this, I think we already did that, but let's query it again. There are, I think, 1576 documents. Yeah, so there are 1576 documents. And let's also see whether our, or rather make sure that our target container should be empty. It should not, we should not have any data inside it. So this is empty, right? So yeah, before actually doing the demo session, let me give you give you a little tour of how you can create your Cosmos DB. So I'll go back. So as soon as I click on create, I get these different APIs as we talked about in the beginning. So you have an option of PostgreSQL, you have an option of MongoDB, Apache Gremlin, Table, Apache Cassandra. So for our demo purposes, we are using NoSQL. And they have mentioned here, under what circumstances or scenarios teams would be using this. So that is always helpful. So let's go back to your Cosmos DB. So we have checked that the source container has data, the target container does not have data. Now, how would we do the migration? For that, we would need a Databricks account. So let me just log in. Go to the Databricks. So I already have one Databricks account provisioned with the name of DBX Brown Bag Cosmos. I'm going to launch the workspace. Why we're using Databricks here is because we want to facilitate the streaming, and this is nothing that I have come up with. The entire documentation is available on the website, which I will share the link, and even the source code is available. I just have tweaked it. I saw some of the code snippets was not working, so I've just tweaked that. I'll make sure that I provide you the link, after this session is completed. So let me just click on workspace. So if you're not familiar with, or if you have not looked at Databricks, this is how it looks like. You have various, tabs: data tab, compute tab, workflows. Compute tab is important because that is where your cluster will be sitting. And if you don't have cluster, you will not be able to process anything. So let's, start the cluster, because it takes, I think, 5 to 10 minutes for it to be ready. And then you have workspace where all your notebooks will be located. You have a choice of using notebooks with whatever language you want, Python, uh, or Scala or SQL or even R. So in this case, we are using Scala. So you have these four notebooks. We are not going to talk about the third one and the second one. Actually, we're not actually going to talk about the source code here, because if I do that, again, that would be a session in itself. Essentially, what we are doing is, you can think of it as this as the parent notebook and this as the child notebook. So based on how many containers you want to migrate, in our case, it is one, as you saw that there is only source container and target container. So that's why, we'll be, so this child notebook would be called only a single time. But in our project, I was, doing migration of 4 to 5 containers parallelly. So what it does is, as soon as you run the parent notebook, it will start 5 parallel threads or 5, parallel executions of the child notebook, and each of that notebook will be responsible for moving data for one container. Now, there's another interesting thing that I want to show you, where we would have to use Chat GPT. Now, let's say, I think most of you guys would already have seen Chat GPT. Uh, I just want to tell you the usefulness. So let's say, you want to understand what this code actually does in plain English. There could be multiple reasons behind it. The first reason could be, you're new to the project, and you don't uh, know what the previous developer has developed, or you don't have the information on the syntax because you're new to Scala. So I did this thing. I just typed in convert below Scala code to plain English, and then pasted the entire code, and then it came up with this particular reply. So it says that the code defines a class notebooks which has 3 fields. So it is talking about the code inside. The code defines a function. So first the class is defined, then a function is defined parallel notebooks, that she takes a sequence of notebook object and the number of notebooks to execute in parallel as parameters. So something that we just discussed. And it also will it actually give you the detail breakdown of what is happening inside your code, which is super useful, because most of the time we would have to scratch our head to understand this. I think with Chat GPT at our disposal, this makes it a little easier to understand. So just wanted to show you that. Let me see whether the cluster is active or not. Cluster is active now. Now, one more question that might be appearing in your mind is, is it hard coded, or is there a capability of, doing migrating the data dynamically? So the answer is that we are doing it dynamically. So all the information about, you know, uh, let me first open that. So you need to have information about your source containers, source databases, source Cosmos DB accounts. Then you need to have the information on the target DB database accounts, target containers, and so on. So you can feed all the information in this Excel, as you can see. And then you can also specify what whether you want to keep that active or not. So in my case, we were using 4 to 5 containers parallelly. So at a given point in time, you will have 5 rows set to active. So this is the file that you see here is in local. What we have to do is we have to upload that file into the database file system. From there, it will read it. And you can see here that the code then reads a CSV file from our database file system and creates a data frame from it. So basically, the number of iterations or number of parallel runs for your data migration will be decided by this file. So I will go to the DBFS location, and you can see here that I've already uploaded this file. Now we are in a position to actually trigger the data migration, and let's do that. So one by one, each of this command will execute. Hopefully we don't see any error. Then you will see that the child notebook will also execute. Let's just wait for a minute. So the child notebook execution has just started. So I've just clicked on that link, and it has taken me to the running notebook where uh, the code is being executed, as we see. So when I remember, we talked about the structure streaming. So this is what the streaming looks like. You have to first declare and define your read stream. Then you have to declare and define your write stream. In this case, we are using a Cosmos DB connector. So that's why you can use Cosmos, OLTP here. So something that is useful. So the streaming has started. And since our data volume was very low, um, I would expect that the data should be migrated by now. But let's see. We'll go to the Data Explorer. And before we do that, we have this Power BI application, which is connected to the target container or the target database. And currently, it does not have any data. You can see here, it is all empty. So hopefully, when the data is migrated, we'll be able to see all those volcano locations throughout the world on this world map. So let me just check whether the data migration has completed. So I'll fire up a query here. And if you remember, the document count or the item count was 1576. So here you go, the data has successfully been migrated. Let's go into the Power BI now. We'll try to refresh the data set. So the data set has been refreshed. Go to the Power BI app, refresh visuals. So you can see here, now we got the data here. And if you hover on any of this, you'll find information like what is the type of volcano, latitude, longitude, elevation, what is the volcano name, what was the last eruption. So that information is here. So far, we have done the migration. Now, what about the incremental data? So the incremental data can come in two forms. One is you have entirely new data, and the other one is you have updates. So now we'll see how that is handled. So for that, there is one JSON file that I've already kept it handy, which is called volcano data incremental. And just to make sure that we don't have this entry already existing in our original data set, we'll just do Control F and find it out. So you can see it is not there. There is a volcano name called Chokai, Chokai, but there is no volcano with the name Hokai. So which means this data is a new data. So we'll go again to the portal. We'll go to the source container, and this is how you upload the data. So click on here, sample DB incremental, open that and upload. So it has been uploaded. Now let's look at the count. So the count was 1576. It should now increase to 1577. Okay. And at the same time, the stream is already running. You can see here, uh, the stream is already running, which means that as soon as you insert the data, the streaming application that we have developed should actually poll or try to query the source DB, and if there is a new data, it will try to bring it in into the target database or the target container. So let's just confirm whether in the target container also we have the same count, and then we'll go to the Power BI. Happening here. Execute this. Yep. So that extra item or document has made its way to the target database. We'll go to the Power BI now. We'll go to my workspace, try to refresh the data set. Hopefully it is successful, then go to the target PBX file. Now let's try to remember the name or see the name. So the volcano name was Hokai. It is situated in Japan. So let's see whether we are able to find it. So you can see here, Hokai is there. If you select it, it will, zoom in to that particular volcano. Okay, so if you just try to zoom out, you can see here that this is situated in Japan. So this proves that the incremental data is working, but there is another inserts are working rather. The new data migration is working, but we still have not checked the updates. So let's go to our source container items. So what we would do is we will just try to change the last known eruption. So right now it is 2013. So let's say, for some reasons, this volcano was active earlier this year. So that way, that means that we can change it to 2023 and see if that works. So we have to have the unique identifier copied so that we can modify the records. So uh, I'm still, new to Cosmos DB, so I'm not sure what would be the right way to modify records in Cosmos DB, but this is what I'm using. So what I do is I actually query that particular item or document, and as soon as it appears on the screen, I will just change it to 2023 and then just update it. Again, we have to think that the streaming is, or we have to mostly just remember that the streaming is still going on. So we don't have to run the job or do anything because the job is already running. It will keep on running unless you stop it. Then the expectation would be that this particular data should be there in your target, or this particular update should make its way to the target container. So let's just check that. We'll go into the target container. Where seed ID is equal to this apply filter. Okay, you can see here the updates that we made are also available in the target database or the container. Now let's try to visually see that. So before we see that, let's see what is the last eruption here. It is 2013. You can clearly see here. I should have given it more, intuitive names, but that's okay. So it is 2013. So now we'll go to the workspace and try to refresh it. It's refreshed. Again, click on here. Sorry, we still need to refresh the visuals. Yeah, you can see here the last known eruption has changed to 2023. So what we see, what we have seen here is that even the updates are working. So this mostly brings us to the end of the session. Any questions, guys? Did it make sense?
Yes, Lokesh.
Okay. Yeah. Okay. I think yeah. If this is something that you're not able to digest, maybe you can do the demo session as we move along. Sorry, as you move along, you can do it with the recorded session that will be available to you. You would need Databricks account, Cosmos DB's account. You can create these accounts as form of in the form of a free tier where you don't have to pay for it. And Power BI, I think, is will be available with everyone. And you might not need Power BI because that is just to make sure that whatever we are doing, we have something that we can see visually. So I also have set up one interesting this quiz just to see if you guys were awake or not. So uh, just feel free to type in your responses as you see the questions. And before that, there is one more interesting slide. This actually data is taken from our project, and these are production grade figures. So we have to increase the throughput. Only then we'll get better response times. So you can see here for transferring data for 197 GB, we use the maximum throughput available. So you have throughput at the source side, you have throughput at the target side. So you have to make sure that the target throughput is higher because you're writing the data, uh, and that goes without saying that if the throughput is higher, you will have to pay more. So make sure that you take due diligence in doing this. So this is something that I wanted to share. So let's move on to the quiz now. So uh, you can type in your responses. Let's look at question number first. So it says an organization whose operations are only limited to their country of origin needs a storage service to save unstructured data. Which Azure service would you suggest they use? So the options are Azure SQL Server or Azure Cosmos DB. So you can either type A or B. Let's see, how many of you have got it right. Yeah, that's definitely A. No, that's not A. Read the question again. Does Azure SQL Server provides the feature to store unstructured data? Yeah, I think Deepthi has got it right. Yes. So that is how you should. It's a trick question, so sometimes when we read it in a flow, that's okay. So what is throughput? An umbrella term used to represent the processing power. It stands for the number of containers used within the Cosmos DB, A or B. Yeah, yes, I think most of you have got it right. Trinad is typing all the options, A, B. That's interesting. So move on to next question. What is online migration? So I want someone, who is a trainee to attempt answering this, if you've understood, or anyone can answer. I mean, whosoever raises their hand first. Anyone want to answer this? What is online migration? No one? Rahul, you want to answer? Okay, let's give. I think Abhinay has raised his hand.
Yeah,
Yeah,
so
Abhinay, go ahead.
online migration is
Yeah. Yeah,
yeah,
go
so
Rahul.
online migration is when your application is live and at the time of your application running, you're trying to migrate the data. So maybe like a streaming process. So you move the data at the time the application is running.
Yeah, that's true. So yeah, application is running. That is the keyword or the key 2 or 3 words, because if you don't want the application to be brought down. So let's move on to the next one. Can you use SQL-like queries for querying data inside Cosmos DB? A or B, yes or no, based on what you've seen here. A or B? Yes. Cool. So yeah, I think most of you guys were awake, which was good. So as I said, the recording will be available. So make sure that you do a demo session. And if you have any questions, you can reach out to me offline. So that's all from my side. Thank you. Deepthi, over to you, please.
All right, Lokesh, thank you very much for the informative session. Thank you one and all for joining the session. And also, Lokesh, there is a request from one of the participants and that if you could provide these, the presentation which you were displaying, right? If you could
Sure.
share it, that would be helpful for them. They'll be reaching out to you in person.
Okay.
All right. Thank you very much, everyone. Have a good evening and also a great weekend.
Thank you, guys.
Thank you.
Enjoy your
Thank you,
weekend.
everyone.
Thank you.
Thank you,
Thank you
Lokesh.
so much.
Thank you.
Thank you, Dipti.
Thank you.
Thank you. Bye bye.
Thank you, everyone.
Bye
Thank
all.
you,
Take
Anna.
care.